Okay, today we're going to be looking at section 9.6, which is the quadratic formula and the discriminant. Hopefully by the end of this section you can say that I can solve quadratic equations using the quadratic formula and find the number of solutions of a quadratic equation by using the discriminant. Okay, so first of all, the quadratic formula is a very big idea. You're going to want to make sure that this is in your notes. And it is x is equal to a negative b plus or minus the square root of b squared minus 4ac all over 2a. So you can solve any quadratic equation using the quadratic formula as long as they are in standard form. So here's an example we got here. 2x squared plus 3x minus 5 equals 0. So we could pick out the a as a 2, the b as a 3, the c as a negative 5. And so you just simply plug it back into your equation, your quadratic formula, I should say. And if we finish this off now, x would be equal to a negative 3 plus or minus the square root of a 9 minus or minus 4 times 2 is 8. A negative 5, that'd be 40 all over a 4. So I end up with a negative 3 plus or minus the square root of 49 all over a 4. And we know the square root of 49 is 7. So I'd have negative 3 plus or minus 7 all over a 4. We know a negative 3 plus 7 is 4 over 4. That would be a 1. If I have a negative 3 minus 7, that's a negative 10 over 4. That would give us a negative 2.5. So our two solutions would be a negative 2.5 and a 1. Okay, so if we walk through a few examples here, in this case, hopefully we can see the a is 1, the b is a negative 4, the c is a negative 21. Okay, so I'm just going to write it up here, negative b plus or minus square root of b squared minus 4ac all over 2a, just so we have it for us. So x would be equal to a negative 4, so it's a positive 4 plus or minus the square root of negative 4, I'm going to put that in parentheses, squared minus 4 times a 1 times a negative 21 all over 2 times a 1. So underneath the radical, we refer to that as the discriminant. So the discriminant in this case would be a 16 plus an 84, still over 2. 16 plus 84 is 100. So our discriminant value is 100. So the square root of that is 10. So I got x equals 4 plus or minus 10 over 2. So if I took 4 plus 10, that would be a 14 over 2 would be a 7. If I took a 4 minus 10, that would be a negative 6 over 2 would be a negative 3. So the two solutions of this quadratic would be a 3 and a 7, or negative 3 and a 7. Okay, if I took a look at this one, obviously we got to get it in standard form, so I'd want to minus the 1 first. So I got 5x squared plus 3x minus 1 equals 0. So if I got a 5, a 3, and a negative 1. Again, I'm just going to write it out up here for us so we have it. Sometimes it's just nice to have it written down so we can see what we're plugging back in. So I'd have x is equal to a negative 3 plus or minus the square root of 3 squared minus 4 times a 5 times a negative 1 all over 2 times a 5. So we got to determine what the discriminant value is. So I would have a negative 3 plus or minus square root of 9 plus a 4 times 5 times negative 1. So I got a 21. No, sorry, a 20, excuse me, all over a 10. So that would be a square root of 29. And yeah, 29 doesn't have a perfect square, but I can get the decimal approximation. And the decimal approximation for the square root of 29 is 5.39 if you round to the nearest hundredth. So I got x is equal to a negative 3 plus or minus 5.39 all over a 10. So if I took 5 or negative 3 plus 5.39, I get 2.39. If you divide that by 10, you would get a 0.24 if you round. Okay, if you do the negative 3 minus, you get a negative 8.39. If you divide that by 10, you get a negative 0.84. So these would be your two values for your x. Okay, let's take a look at one more. So if I add this 5 to get that into the standard form, I'd have x squared plus a 4x plus a 5 equals a 0. So a is a 1, the b is a 4, the c is a 5. If we use the quadratic formula, I'd have a negative 4 plus or minus the square root of 4 squared minus 4 times a 1 times a 5 all over 2 times a 1. So if I just do my work here now, the square root of 16 minus a 20 all over 2. This here would then be a negative 4 plus or minus the square root of a negative 4 over a 2. So if I tried to take the square root of a negative 4, I would find out that's not possible on my calculator. So we say that there's no real solution. So why is there no real solution again? There's no real solution because we can't take the square root of a negative. So again, that discriminant value is a negative, so we cannot take the square root of it, so there's no real solution. So the second part of your assignment today, we're going to be looking at something dealing with the discriminant. So the discriminant, this here is a great chart to have copied down. So if the discriminant is greater than 0, if we were to graph that thing, we would find that there is two x-intercepts, point here, 2 x-intercepts, which means there's two real solutions. Okay, if we had the case where b squared minus 4ac is equal to 0, or the discriminant is equal to 0, we'd have one solution. Crosses the x-axis, only one spot, one real solution. Okay, and the final case would be if b squared minus 4ac, or the discriminant, is less than 0, which means it's a negative. There would be no real solution. It does not cross the x-axis, so there is no real solution. So the last piece of your assignment today will simply be asking you to use the discriminant to determine the number of solutions. So the discriminant is simply this piece right here, b squared minus 4ac. So we still need it in standard form. So I got x squared plus 4x plus 3. So the a is a 1, b is a 4, c is a 3. So b squared would be a 4 squared minus 4 times a 1 times a 3. So that would be 16 minus 12, which would be 4, which tells me it's greater than 0, so there are two real solutions. Okay? If I looked at this second one, I'd have to add the 8x and add the 18. So I'd add 8x and add 18. And I'd have 2x squared plus 12x plus 18. So the a is equal to a 2, the b is equal to a 12, c is equal to an 18. So if I did the b squared would be 12 squared minus 4 times a 2 times an 18. So 8 times 18 is 144. So I've got a 144 minus 144, which gives me 0, which tells me that there is only one real solution. Okay, and then this last one, if I looked at this one, I'd say that the a is a 1, b is a 0 in this case, and c is a 5. So b squared would be 0 squared minus 4 times a 1 times a 5. So we got 0 minus 20, which is a negative 20. So if it's negative, we say that there is no real solution. Okay, I know I went kind of quick, but hopefully this is making sense to you. But that is a wrap.